Hi, Vaibhav. Hello, Shakil.
Hello, good morning, sir.
Hello, hello, sir. Good morning.
Okay, let's wait for a minute. We'll start. Any questions from any of the previous session? Ask me, please. Okay, I'll take that as a no.
Sir, I have questions, but not today. We'll, we'll ask you maybe next week. I just have to go through a couple of things and then uh, just make a list of my questions I have.
Sure, sure. Feel free. Um, so now let's begin. I'm sharing my screen now. So our cluster is up. And let's see. Okay, we are good. So what we had done yesterday we were talking about second kind of service, which is the NodePort service. And the manifest for NodePort service is present in Kubernetes folder, which is this. So what we had done yesterday, we have to edit this. Yeah. Okay. So now what we did in this, the first thing which we started with is API version, and this API version is again coming from Kubernetes documentation, which is absolutely managed by Kubernetes. Second is kind of the object, which we saw in cluster IP also, which is service. Next thing is metadata. I give the name. Let's give a name of our own choice because name is something which we control like the way we seen yesterday. So a couple of things which we discussed in detail in our previous manifest. I'm just going to put the values on it. I won't talk much about it, but anything newer which comes, I'll talk about it. So now here I'll say my NP service. And next thing is selector. So selector is something which we did in case of our cluster IP also. So what we did, we put this as the value. And I'm going to put save value here also in order to bind this with my replica set. So now this is the selector. You have to ensure that you do have a replica set which is having these two tags in it. Next thing is ports. So what I'll do first, I'll delete this couple of extra lines. Okay. Now two things which I would like to talk about here. The first thing is type. When I was explaining cluster IP, there we did not write any type. That basically means what is this keyword type? What this keyword type says? This keyword type says that what type of service you are creating. So with this manifest file, hope you understand that we are creating a service. Now, if we do not put any type for the service, then by default, Kubernetes understands that you want to create a cluster IP type of service, which we discussed in detail in a previous session. Now, I want to explicitly mention that what type of service I want to create. Now, in order to mention what type of service I want to create, I'm going to use a keyword called type and put the name of the service which I want to create. And the service which I want to create at this point is node port type. This is the second type of service. With the node port service with cluster IP, what we learned, we were able to enable communication in between pods only. But with node port, we will be able to enable some external communication also by exposing some node port as well. Like the way we saw in our diagram also, we have to expose some port we have to expose some port in our node also. Unless we expose any port to the node, traffic won't be able to enter into the node. So now in order to do that, what we are going to do, we'll type first as we'll put the type keyword and we'll put the name of the service as node port. Selector is something which we spoke earlier. Ports is something which we discussed earlier. So this port and this port which we talk about, this port is nothing but the port of the pod. Target port is nothing but the port of the container. One new keyword I'm introducing, which is node port. So now this node port is the port of the node of your virtual machine. So node, instance, virtual machine, they are all in same. So this node port is the port which will be exposed there in your virtual machine. Now any of the traffic which is entering will enter through this port only, through this node port only, which is 30,007. Now this range, there is a range for this, which is 30,000 to 32,767. So there will be always a range for node port in node port. Range of node port is 30,000 to 32,767. You cannot put anything beyond this. You have to put a value which falls in this limit only. So now this is the manifest file for node port. Now we are going to use it. Now it is quite straightforward, very similar to the cluster IP. Only the difference which I did is I put a type as node port and I have assigned a port to my node also. All in same. Any question in this? Okay.
Sir,
These
this
ports,
node port,
these ports are specific to Kubernetes.
Yes. Yes. Yes.
They have nothing. They have nothing to do with TCP ports or anything.
No, they have nothing to do with TCP port. No, this port is very specific to Kubernetes application, and this port will be opened there in our virtual machine. Nothing to do with
Because
TCP and other things.
port 80 is actually a TCP port.
Right. Yeah. Port AP. It's not only TCP. For various application, we use this port. For Nginx, you use this port. For different type of service, for different type of application, we use this port. Even I think for HTTP, what is that port? Yeah, HTTP port also 80. So
yeah, so that is TCP.
TCP is different. HTTP is different. TCP is Transmission Communication Protocol. HTTP is Hypertext Transmission Protocol. So these are two different protocols.
Okay.
I would say.
Yeah.
But
so
yeah.
we need to have this port open on the firewall or anything?
Not this port open, but yes, this port has to be open there in firewall.
Node port, okay.
Node port has to be open there. Yeah. Okay. Well, you asked something.
Sir, this node port, we can assign any port in between that range, right? Which is reserved for.
Yes.
Okay.
Yes. But it has to be in 30,000 to 32,767.
Which is reserved for the
Which is reserved for Kubernetes usage. Yes.
Okay.
Okay. Okay. So now save it. Now save it. And what I'm going to do is, but even before you do, you have to ensure that you do have a replica set ready. Let me see. Get rs is the command. Okay, it's not there. So now I have already previously created file, right? Do you remember? We had created this file. So I'm just going to apply this. Okay, now kubectl get rs. It is there. Kubectl get pods. You should remember these commands. Remember, because in interview people are asking these commands also. You must know these commands also.
And what about the commands that we are writing in our manifest in the script?
Those also you have to know.
Really?
But those are not tough. Actually, if you practice maybe 10 to 15 times, if you'll write it, you will start understanding that flow. If you know the flow, nobody will ask you to write complete manifest maybe. But yes, you should have those understanding of what should come in with which type of file. Like match labels should be used in certain files, selectors should be used in certain files. So basically, interviewer wants to understand if you know the usage of match labels, if you know the usage of selectors, for what purpose we use selectors, for what purpose we use match labels. What happens in case if you don't use it? You must be aware of those logic. Interviewer will check on that.
Okay. And in production, we use VI notebook.
Yeah, it's editor.
Yeah,
Like
editor.
Notepad, yes.
Okay. So this is what we use in production.
Yeah, and that is Linux node. Linux, like it doesn't matter if it's production or non-production. In Windows, you will use Notepad only, right? So similarly for Linux, since most of the machines are Linux, in production, since most of the machines are Linux, so you have to use VI only.
Okay, sir. Thank you.
Okay. Okay. So now what happens is it's there, right? It's there. So now, what I was doing, okay, let me just check. Cat replica set. So this should have Nginx image present within it, right? Nginx image present within it should be there. Now what I'm going to do, I'm going to associate this with with your service. So first, let's see in case if I'm able to access Nginx application on this instance. So which node it is running on? Let's see, kubectl get pods -o wide. You will get to know which node this is running on. This is running on 7CADE. 7CADE must be a node in your list. Let me just 7CADE, yes, it's there. And let's see if I am able to access this Nginx application or not. So no, it's just going to rotate for indefinite period of time and then that's the sending up with error. We are not. Now I'm going to associate with it with a service. So in order to associate with the service, which is the NodePort service, we already saw this cluster IP. So NodePort service, I'm going to apply now. Apply -f and give the name, and it's created. Now if I'll say kubectl get svc, what we saw earlier, we had only cluster IP type of service, right? We had only this type of service which we saw earlier. Now what you see, we have a node port type of service also. And can you see this? This is 30,007, right? The port which is open is 30,007, which was not showing earlier, right? Which was not showing earlier. This is not showing 30,007 port, and this is the node port. Now let's see if I'm able to access the application on this port or not.
And sir, it's showing 80:30,007. So what does that 80 : mean?
This 80 is the port of your, because when we were learning Docker also, you remember, I was giving two kind of ports. One port was my node port and another was my container port. Now in this case, we do have the concept of pod. Rather than talking more about container, in terms of Kubernetes, we talk more about pod. So now when I was writing the manifest file for this, here, you see what this port is? This port is the pod port. So here, this first 80 means pod port, and the next 3007 means port of your node.
Okay. And this svc-np.yml, you gave this name to the file?
Yes.
Okay.
Okay, any other question?
That's good, sir.
Okay, cool. So now it's there. And now let me just check in case if I'm able to access the application or not. And okay, I checked, and now you see the application is up, right? Application is up on which port? On 3007. It's not available on port 3008. No, it will just keep rotating, right? It is not available on port 3008. On which port it is available? It is available on port 3007 only. right? It is available on port 3007 only and in this IP only, and it is available globally. Even though if you will check, you will find that it's up. So now what is happening? Previously you saw when I was working on clustered IP type of service, I was not able to expose my application to web. But with this, yes, I am able to expose my application to web. Right? I'm able to expose my application to web. So this is the advantage of having a node port type of service. Clear? Are you able to understand? And this happens in
Sure.
production environment. This is what we do in real, because eventually what we have to do, we have to expose our application to end user, right? And what is that application? Application is in the form of image. I have created a replica set. The replica set is having the image. I've exposed that replica set by using service. Now I'm able to access my application over web. I mean, exactly, it's Amazon, it's Google, whatever it is, you are able to access the web page like this only. Now this is also a web page. If you'll see, this is also a web page, and this is available on my IP, my server. So now what Google is doing, what Amazon is doing, they have their own IP, they have own their reserve IP, and now they're exposing it to their application. And if you, being a customer, will try to access this IP, this port, even you will get this page. But this is not running on your machine. Understand it. This is running on my machine, my account, but you are able to access it like a customer. Understood, right?
Yes, sir. But still have some concern about that because if you go to the CLI, see it says 80:30,007 TCP. So still have some concern about that if it is a TCP port or what, so
No, it's not a TCP. It's not a TCP. TCP is a protocol. For any communication, you need to have UDP TCP protocol. See, I'm not going to explain OSI model now, but
yeah.
understand, in short, this it is not a TCP port. This is the pod port.
Okay.
So, Shakil, here 80, you can consider that is port number 80, and that is running over TCP. But I mean, your concern, I'm not sure. What is your query?
Simple, Shakil, understand it. 80 is the pod port. Here, what is happening? If you see this map, there is a mapping, right? There is a mapping in between node port and pod port. You see, there is a
Yep.
mapping in
Yes,
between
I
node.
understand that, sir.
Yeah. So now this 80 is the pod port, and here it says there is a mapping in between port number 80 and port number 3007, which is the node port.
Okay.
So that any traffic which falls on 30,007 will be routed to port number 80.
Okay, sir.
Okay. 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 Fair enough. Any other question? Huh?
Sir, so in this, can you please show that diagram again?
Mhm.
I mean, in real-time production, so we are running this Nginx application on this port with port 80. So let's
Absolutely.
assume that we have another requirement with some different application which will be running on different port. In that case, we'll have the same public IP with different services, right? If we run any
Public IP, public
Mhm.
IP with different port. The good point. There might be another, what Vaibhav's question is, there might be some other application which is using the same port 80. Nginx is port 80, HTTP is port 80. Even there are some other services like HTTPD that also uses port 80. So what happens in this case? In that case, if you do have a pod which is having port 80 Nginx application, which is having port 80 HTTPD application, what you can do is you can have different port in your node, right?
Yeah.
30,007 port is exposed for Nginx application,
Nginx,
and
okay.
but 30,008 may expose to HTTPD application. So it doesn't matter if they are having same 80 port number in their pod. You do have different port reserved in your node for different type of application. You can do that. Yeah, clear?
Yeah.
Okay. See, these things should be clear because these things are logical things, and you interviewer try to judge you on the basis of your logic, because nowadays anyone can write this script, right? You go just to chat GPT, you will get the script. Everything is there. Whatever in this kubernetes.io, Even I don't need to write any manifest. I can just copy and paste it here. But you should know the logic. Okay. Now another kind of service. Another third kind of service is the load balancer type of service. Now, what is load balancer service? Like the name says, load balancer. Now, what is the drawback with this? The drawback with this is, you see, there should be like IP address, port, and perhaps whenever you are creating a domain, that domain will perhaps should have uh, multiple IPs defined, each IP for each node. Maybe you are having, as of now, I'm using 2 node. Perhaps in real time, you will be using 20 nodes. Now, every time I have to use IP of my node to expose my application. Right? This is the IP of the node, which can be different for different node, which can be different for different node. This port will remain same, but the IP of the node is different for different nodes. But in real time, what happens in case if you are giving IP of the node and creating a domain, and if for some reason that node goes down, then the domain will be inaccessible. Rather than doing that, what we normally do, and it's a kind of general networking practice, what we do, we create a load balancer. What we do, we create a load balancer, right? Let me just go to Paint. It's easy there. What we do, we create a load balancer, and behind a load balancer, we put multiple servers. All right. Behind load balancers, we keep multiple servers. Now, what is happening? The traffic from any of the user's machine, the traffic from any of the user's machine will first come, and the traffic will first fall. The traffic will first come and will follow to load balancer. From load balancer, now load balancer will route traffic to different places. Now, how many IPs I do have? Only one IP, which my customer will know. Customer will know only one IP, and doesn't matter if the underlying node goes down. Doesn't matter, because load balancer will look for a healthy machine and will route the traffic. So consider this is load balancer. Consider this is load balancer, and all other machines are your node machine. This is node 1, node 2, and node 3, right? So load balancer, the advantage of load balancer is load balancer will give you one public IP, and underlying could be different nodes with either private IP or public IP, don't care. It is the responsibility of load balancer to route the traffic. That is the main logic behind a load balancer. All right. So same thing will happen in this case also. Now, if I execute kubectl get SVC, what you're getting here is you are not getting any external IP, right? You are not getting any external IP. Doesn't matter it's cluster IP or doesn't matter it's node port service. You are not getting any external IP. Why you are not getting any external IP? Because the feature of these type of services, you have to use respective node IPs only. What do you mean by external IP? External IP is the IP which is outside the range of the cluster, right? Which is outside the range of the cluster. Load balancer will be outside the range of your cluster. You will get an IP. Normally what happens is networking team will say, okay, fine, I'm going to assign you a IP. And this IP you have to use while you are creating load balancer service, right? You have to use this IP while you are creating load balancer service. And what happens? Any of the external traffic will know this IP only, and it will be load balancer who will be routing traffic to all the nodes which is a part of that cluster. That is the logic behind a load balancer service that we are going to talk about. Any doubt in understanding what a load balancer is capable of doing? Okay,
Yes,
I'll take the
yeah, we have the concept of how load balancer work, but we just want to see in the diagram, where does it sit in this architecture?
Okay. So this is the cluster. This is where it's set. This is the diagram. This is how it works in simple terms. Okay, now let's go and let's
So
create.
so the load balancing service sits on top of the cluster.
Yes.
And these are worker nodes.
Yes.
Okay.
Okay. So now I'll create a third file, which is load balancer.yaml. Now, while creating load balancer, what I'm going to do is I'll take again help of Kubernetes.io. .io. And here I'll type load balancer. Load balancer. And you get here. Again, just search for load balancer service. And this is the one. Very similar, right? Very similar. What is the difference? Let's copy this first and then we'll talk about it. And let's paste it here. What you're saying? API version, kind, metadata. Let's give a name to metadata. And this will be my LB SVC spec selector. Let's give a name to the selector. Now what I'll do is I'll remove the previous service one, so that previous service as in NodePort service. I'll detach the NodePort service from my this one ReplicaSet, right? So let's me detach it first. kubectl get svc, and how will I detach it? I'll remove this svc. kubectl. Why I'm removing it? Because I have only one replica set, and first I associated that replica set with NodePort service. I exposed the application. Now I want to use load balancer SVC to expose my application and not the NodePort one. That is the reason I'm removing that. So in order to do that, what I'll do, say delete SVC. This is the name of my NodePort SVC. Deleted. Now get SVC. It's not there. Now if I'll come and if I try to access this, let's see what happens. Gone, right? Gone. You're not able to access it now. Now what I'm going to do, I'll use the load balancer to access it. So what is going to be the name of my load balancer service? My load balancer SVC spec. I have to get the tags of my replica set. So cat replicaset.yaml, and let's open the file. And let's delete this. And put it in a proper space. Okay. What is this cluster IP? Why are you here? Type load balancer, status load balancer. Okay. Don't want to confuse with lots of extra information. Okay. So now let's try to understand this. Okay. Something else is also gone. What is gone? Then type is also gone. So let me just write type quickly. Then I'll explain this. Load balancer. Spelling and cases are very important. Load L capital, B capital, load L capital, B capital. Fair enough. Now let's try to understand this. See, the first thing always it starts with API version. Kind is service metadata. I'm giving the name as my load balancer SVCs. Specification type. Previously, what I gave type when I was working on NodePort, I gave the type as NodePort type of service. Here, I want to create a load balancer type of service. Henceforth, I gave the name as load balancer. Selector remains same. And in this case, what I have done, I have just given the target port, which is not the target port, the pod port. The pod port, which is this, and the target port is also needed. Let me just put that first. And what I'll do, I'll keep the target port and pod port same. And I'm putting emphasis on keeping the target port and pod port same because that is the practice which we follow in real time also. Always try to keep pod port and target port as same. Do not keep it different. Otherwise, it unnecessarily creates confusion. Now, what it is having? It is having very similar to cluster IP. If you remember, the port, pod port, port is pod port, target port is container port, protocol, TCP protocol for communication, and here is your app, the applications, Nginx applications tags. Selector is the same keyword. What is the change in between cluster IP and load balancer, and the load balancer type of service is in load balancer service, I've just mentioned the type as load balancer. That is the only difference. In node port, I had to specifically mention, right? I had to specifically mention a port of your choice. But in case of load balancer, you do not need to mention. You remember the concept of small p and capital P, right? Consider your node port service is small p and your load balancer service is capital P. In capital P, you did not had to give any port of your choice. It was Docker which was selecting, which was creating that port for you. And second thing is, in case of small p, you had to give a port of your choice. So node port as small p method in Docker and load balancer as capital P method in Docker. Very similar, like the way I wrote cluster IP. Just the thing which I mentioned is type as load balancer in order to create the load balancer service. I'll give a quick pause. Any doubt in this? Okay, I'll take a sec.
So
Yeah.
in this ports, so target port we can customize, we can change it. But this port 80 port, is it this is standard port 80? So this can I mean, can we this customize, or this should be the same with the actual services like 8443, or
Normally, what
Mhm.
happens is the kind of application which you have hosted in your container, we use that port only as your pod port, but
Okay.
it's not as in you cannot customize it. But in order to customize it, you have to, there are like some complicated configurations for that.
Uh,
You have
no, I
to,
mean the port perspective, configuration perspective, we cannot change this, right? This services needs to be run on their
yeah,
uh, yeah.
those are service default port. Yes.
Okay. Yeah.
But now, I mean, see,
So,
if I'll talk from the high level, yeah,
Mm.
go ahead, please.
sorry, can you tell? So, which one is equivalent to small p?
Node port is equivalent to small p.
L- Node port, you said?
Yes.
Okay.
That's it. Any other question?
Sir, small p is referring pod port or node port? Because node port we can customize or we can say it's a target port.
Yeah, small p is node port. In small p, you can customize it. In capital P, you do not need to customize it.
So this capital P is belongs to where? Like node is clear and the capital port is
The
for
capital P. You have gone through Docker recordings?
not sir. Just now.
Sir, I
You,
again
you,
got confused. Your node port
yeah, ask your
P,
questions.
small p is the port is
Okay.
taken automatically.
No, no, no. Uh, Go through Docker recordings, please. Small p is not port
Small
taking
p is
automatically.
customized.
Yes.
Okay.
You cannot forget your past sessions. That is the first
Okay.
ground rule. Hmm. Any other question?
So what is so here you said load balancer port is equivalent to what?
Capital P.
Capital. Okay.
Any other question?
And what is the other one that small p?
I'll write it because it's like I'm saying it 6 to 7 times now. Node port is equivalent to small p and Docker. Load balancer is equivalent to capital P. How can I remove these diagrams? Capital P and Docker. Any other question?
Sir, in load balancer, we have number of nodes. Okay, behind the load balancer.
Yes.
Behind the load balancer, we have number of nodes. So in this case, for now, we are defining single node. In case we are using multiple nodes, then
Actually, we are defining two nodes. The diagram talks about single node, but
okay.
in our real time also we have two nodes. kubectl get nodes. We have two nodes. So now 2 can work, 20 can also work.
Okay. Got it. Yeah.
Okay. Any other question? Just give me a moment. I'm getting a call. Just a moment. I'll be back. Okay, sorry guys, I'm back. So now what I'm going to do is I'm going to create a load balancer type of service. And where we are, kubectl get pods, kubectl get svc. I'm just executing commands over and over again so that you remain aware what is going on. So now I'm unable to access any application either by using my 3007 port or by using my node port IP. Okay, I'm unable to access it. Now I'm going to create a load balancer type of service. Sorry for typo. And here, this is my load balancer, and this is the app tag I'm using. I have exposed only the pod port and container port. There is no concept of node port. I have given a type as load balancer. Now I'm going to apply it. kubectl apply -f load balancer dot YAML. Okay, done. Now kubectl get svc. Now see what is happening. And this is what I was referring to. This time I will get one external IP. External IP will be this IP, this load balancer IP, all the traffic. And normally what we do is we give a domain name to these IPs. We just give a mapping, a kind of DNS mapping we do, wherein we just give a name to this IP. Like google.com is actually not google.com. It is having some IP behind it. So now this IP is the IP which as of now is getting created, which is pending. It will take few minutes, I think, for that IP to get created. But that IP will allow you. And what happened? You see, it also got a port. Why it got a port? Because because load balancer is equivalent to capital P, auto assignment of port. You don't need to use that. That is for sure. But it has assigned a port for you. And this is how it works, right? Give it some time. It will create one load balancer. If my AWS will allow, then we will see how to use that port. But as it comes, what I have to do is I have to just copy that external IP and I have to just put that external IP there in the browser to ensure that I'm able to access my application by using that external IP or not. That is what I'll be doing. All right. So this is how it goes. Okay, so now this is about service. Let's see, give it some, normally it takes time, maybe 15 to 20 minutes for, now what is happening at the backend? This load balancer is trying to assign some IP to me. It takes some time, normally, approximately 15 to 20 minutes. It takes for that IP to assign. We'll wait. Now, yeah, any question?
So sir, that IP will be different from the node IP, which
Node
we
IP. Yes, yes. Always the load balancer IP domain is different from your node IP. Yes, because node is separate
yeah,
server.
yeah.
Load balancer is a separate service. Yes.
Okay.
Any other question? Okay, fine. So now let's talk about now what we learned. We learned about pod, we learned about ReplicaSet, we learned about service. Now we are going to talk about next high level component, which is deployment. Why deployment is needed. Let's first we'll understand. I'll talk a bit theory about why do we need deployment first. Then I'll go to the practicals of deployment. There we will see what is the deployment and how it basically works. So understand it in this way. Any of the service which you are going to use, and understand this very nicely and very simple terms, because Kubernetes usage scripting may be complicated, but its logic is very simple, because its logic is to resolve real-time problems of any of the customer and IT industry. So Kubernetes is beneficial. Kubernetes is so widely in use because of only two reasons. Its main purpose is to resolve IT industry's problem and to resolve customers' problem. What was customers' problem? Customer had to access multiple versions of application, any upgraded version of any application pretty much easily. That is my problem being a customer, right? What I want, my Android application in my mobile has released a newer version of Android app. I have to install that, because if I won't install, my phone will be slow, my phone will be vulnerable. Same is going to iPhone also, same is going to iOS also, same goes to Windows also. Windows 11 also, after 2 years it will say that I am going to stop the support for Windows 11. You have to upgrade to Windows 12, Windows 13 or Windows 14 by that time if they launches those version. So you have to upgrade. Being a customer, that is my problem, right? I have to have different versions of application should be present somewhere so that I can download it and I can use it. What is the problem of IT industry? Problem of IT industry is every now and then they have to release newer version. So releasing newer version of any application is whose problem? IT industry's problem. Downloading those newer version of application and putting it in their system is whose problem? Customer's problem. And that is what Kubernetes is going to do. In order to deploy multiple versions of application, say now you do have already one version of your application ABC. The name of your application is ABC. You have launched the first version of your application ABC. Right? You have launched the first version of your application ABC. Let- And what you have to do is, once you launch the first version of your application ABC, what next you want to do? After 3 months, you want to bring in another version of your application ABC also. Right? So now when you brought in first version of your application ABC, where did you keep? You kept in your pod, right? Because pod is the basic building unit in Kubernetes, you know. So what you have done, you have just kept the first version of your application in pod. Now what you have to do, you have to launch newer version of your application. In order to launch newer version of application, you need you need different set of pods, and those different set of pods will contain newer version of your application, right? So what you have to do, you have to take the previous version of application down by taking down all the pods which was holding it earlier, and bring in newer set of pods which will contain newer set of applications. Now understand it very clearly, and this is the thumb rule of any of the containerization or any of the orchestration platform, that application is present in image. Application always will be present in image. This is the thumb rule, right? This is the thumb rule which you need to keep it in your mind. So now what you have to do, is you have to do this. Now what you have to do is, now we are going to talk about another very, very important type of service, which is deployment. Now, whenever you're talking about deployment, then some of the things which you remember. So now we are going to talk about a very important service, which is deployment. Now, whenever you're talking about deployment, the main purpose of deployment is to release multiple versions of applications, so that customers are happy that they are getting multiple version of existing application, and even IT industry guys are happy that they are able to bring in multiple version of application. Now consider that your application name is, right? Consider that your application name is something ABC. Your application name is, say, ABC, and what you have to do is you have to just expose your application ABC to end users. So what will be your way? How will you be able to expose your application to ABC? Can anyone give me some idea how you have to expose application ABC to end users? Now your application name is, say, ABC. This is your application. And for this application, what you have done, you have created for this application, what you have done, you have created couple of, what you will do, you have created couple of, say, pods. Consider this is first pod, pod 1. This is second pod. This is second pod, pod 2. And this is third pod. This is third pod, pod 3. And this pod 3 contains version 1 of your application. Now what IT industry has done, after the duration of 3 months, after the duration of 3 months, what IT industry has done, IT industry has launched version V2. right? IT industry has launched version V2, and now when IT industry has launched version V2, there also for V2 also there has to be some pods. But what they have to do? Have you ever seen two different versions of google.com running at the same time? Have you ever seen two different versions of amazon.com running at the same time? Have you ever seen two different versions of Flipkart, Alibaba, any of the website which we very commonly used running at the same time? No, no. It cannot happen, right? Always one version will be available at any point of time. So what they have to do? They have to take these pods down, which contains version 1 of application ABC, and bring equivalent number of pod up in version 2. So what they are going to do? They are going to take P1 down here and take maybe some other. If you get confused with the name of the pod, I'll say I'll say maybe A1 pod, which belongs to version 2, right? Which belongs to version 2. So now again it goes down, P2 down, and A2 comes up. A2 comes up. P3 goes down and A3 comes up. You don't need to change the names, but yeah, just for simplicity, just to show you that they are different pods with different set of images, which is the version 2 of the same application ABC. I gave the different name. So what is happening? This is not possible with ReplicaSet. ReplicaSet is able to create three different pods together for you. But if you'll ask ReplicaSet that, hey, I want to upgrade it to newer version of application, ReplicaSet is not capable of doing that. ReplicaSet cannot do that. For that, you need some higher level object, some more stronger Kubernetes object, to which we call as deployment. What deployment will do? Deployment is capable of taking your previous version of application down and bringing in newer version of application in existence. So this is one of the biggest reason, one of the most important reason of deployment. One of the most important reason behind deployment is performing version upgrades, right? Performing version upgrades. So whenever you are doing version upgrade, there could be multiple things, right? There could be multiple things. So maybe what happened is you have upgraded from V1 to V2. So first thing what you have done, you have done the upgrade. The first thing which you have done is you have done the upgrade. And when you have done the upgrade, in order to do the upgrade, what you have done, you had V1 existing and you had upgraded it to V2, but V2 did not work properly. It did not work properly. So now if it is not working properly, what you will do? You will roll back, right? You will roll back. So rollback is another feature. Rollback is another feature. So you will be able to roll back from V2 to V1 also. And this rollback can be done only with deployment as the object. It is again not possible with any lower level object. For that, you need deployment as the object only. So what are the different advantages you are saying? With deployment object, you are able to upgrade from one version to another version. You are able to roll back from previous version to any of the lower version. Manifest file of deployment is very similar to ReplicaSet, very similar to ReplicaSet, but it is capable of doing more advanced features. Maybe because of its API version, or maybe because of the way it is created by Kubernetes, it is able to do some advanced features. All right. So this is the theory about deployment. Any doubt in understanding what deployment is capable of doing? Ask me, please. Okay, I'll take that as a no. Now we will see, right? We will see the usage of deployment. Like the way I said, deployment manifest file is very similar the way we write replica set. So I do have already replica set file present. I'll just copy. CP is a Linux command which is used to copy, like normally if you have to copy a notepad file, and perhaps create a replica of that. What you do? You just do a right click, copy and paste. But in Linux, we don't have that right click. We have the command. So cp is the command which we use in Linux to create a copy of a file. So what I want to do, I want to create a copy of the file replica set and I want to name it as deployment.yaml. I'll do some editing for sure in the file, but more or less syntax remains same. So now vi deployment.yaml. Now let's refer our Kubernetes documentation. See, every time I'm referring Kubernetes documentation. Why? Only because of one single reason, to check the API version. Because even I don't know if Kubernetes is changing their API version. I don't know. So deployment. Okay, you see the API version of deployment, it's apps v1, the API version. Okay, same as replica set itself. So API version is apps v1, kind is changing, kind is going to change, and this will become deployment now. So if you understood replica set, it will be very easy for you to understand. Deployment metadata remains same, labels remain same, and you can keep same or different. That's fine. You already know the usage of label. You already know the name, so I'm not going to talk about it. Specification, replicas, selectors, match labels, template, everything else remains same. There is no other change. Just the name, just the kind is going to change in case of deployment, right? Just the kind will change in case of deployment. All other values remains exactly same the way we learned in replica set. But with this kind, remember, with this kind, you are getting additional feature like upgrade and rollback, which we will see in our demo itself. That's it. Any question? I don't think there should be any question in this, but any question in understanding what the deployment set looks like? This is very similar the way we did in replica set.
So what do we call deployment? A service, an object, or tool, or what?
Yeah, it's an object. It's a
Object.
Kubernetes object.
Okay.
Yes. Service is different. Service is mostly used for networking. We have to integrate deployment also with service. In order to expose application, we have to integrate this also with service. Any other question? Okay, I'll take it as a no. So now let's do one thing. We will talk. We'll take some different application. Because Nginx is very generic, which we are using for pretty much long now. So what I will do is I will take some other application where I can talk about upgrade of the previous version and other things. So there is one one image which I'll take to show you upgrade, which is having multiple versions, is Docker Hub. Okay, it is the one which I had created is lead DevOps, slash kubeserve. So this is one image. This is just one image which I'm going to use. Lead DevOps kubeserve. And I want to show you this is having multiple versions in it. See, there are three versions, V1, V2, and V3. There are three versions of this image. I wanted to show you this because, understand it, the main purpose of deployment set is to upgrade from one version to another version. And in case if the upper version, if the higher version do have some issues, some complexity, you will be able to roll back also, right? You will be able to roll back to any of the previous version also. So this is the main purpose. This is the main reason behind having this. This is the main reason behind having this this specific image. So I'm going to use this image instead of using the generic image which we're using till now. I'm going to use this image. And this is how in real time also it will happen. This is how in production situation it will remain. You will have one image. There are multiple versions of the image will be there, and you will be asked to upgrade from one version to another version. So I'm going to use this image only. You are following, right? This is Docker Hub, which we did even earlier a number of times. Hope this is clear. I hope you are not getting confused with what we are doing in demo, right?
Yes, sir.
Okay. Okay. So now what I'm going to do is here you're given deployment and metadata, and you're given name, and you're given specification, replicas, selector, match labels, type, and you are given this, and you're given template, and you're given metadata, labels again, and then you're given the name of the label, and then you're given the specification, and then things. You hope you understand this labels could be different, right? This labels could be different from one system to another system. You can give something else. So maybe I'll try to change this so that you should not get confused that every time I have to use same thing. So maybe I'll try to change this, and I'll keep it maybe simple this time. Type. This is another tag which I'm using. Server. And this type, okay, I don't get confused with this type and the type which we used in service. Maybe what should I name it as app name? Something else. Here also app name as web server, and here also app name as web server, and then the container C1. You can give some different container also. That's fine. But the image which I'm going to use is the one which is for me, right? Which is for me. So now I'm going to run this. Now I'm going to run this. So first I'll just do some cleanup. Git rs. Let me just clean this. You can keep both, no problem, but I want to clean it. kubectl delete rs and deleted kubectl get rs. Okay, I cleaned it up. You can keep both again, but I don't want to complicate things. kubectl get deployment is showing nothing because I did not create anything yet. Now, in order to create, what I have to do? kubectl apply -f deployment dot YAML and hit enter. Okay, created. Now if I'll execute same command, it says yes, sample sorry, I should not have given this name. Delete deployment. This name is for replica set. I should have changed it. My bad. Give a name to this, and this I will name as sample deployment. Very same as replica set. Get deployment, nothing. It's created again and created. And now, right? And now if I'll see, yes, 2 out of 2 deployment ready, even the pod will be ready. Very similar like the way we had replica set. The pod is having name as sample deployment, and this is the name of the pod, right? This is the name of the pod which I got. Now a question to you, I have pods running. I have application within the pod. See, the pod status is running. Will I be able to access the pod? What do you think? Will I be able to access the pod?
If the port open, then of course we can. And if the deployment open the port automatically, then we should be able to.
Yeah, but is deployment capable of opening the port, or should we use some other object for that?
That we have to learn.
No,
If
in general, see,
deployment can do
you
this.
know what a replica set, and I said the deployment is very similar to a replica set. What you will do to open a port or open a traffic?
So, sir, if it is deploying the similar feature like replica set, then it should accessible.
Then it should
Accessible at the port.
no, it won't be accessible until unless you associate a service
Service, yeah.
to replace. That is what we did, right?
Yeah.
We were not able to access until unless we associated a service to our deployment set, to replica set. Same thing happens in case of deployment also. It won't be accessible until unless you associate a service to your deployment. Right?
Yeah.
Okay.
Yeah.
So services associated on the previous deployment doesn't get copied over to the new deployment.
No, it won't. By default, it won't.
Okay.
Okay, fair enough. So today we'll stop here only, and tomorrow I'll show you how the setup in between service and deployment set. But guys, practice, right? It's very important. I know you're confused, but this confusion won't go simply. You have to practice. You have to write manifest. Okay, so let's connect again tomorrow, and then we'll talk about.
Sir, I have a question.
Go ahead.
Yeah. Sir, in my company, it's an open stack. So, like, how or what I need to do learn OpenStack, because we are running on AWS. How it is different, or how things are similar when I work with OpenStack?
OpenStack is not AWS. You need to understand that. OpenStack is a third-party platform. It's another service. It's another vendor altogether. But underlying, they use Kubernetes. So OpenStack is a kind of GUI, you can say. As of now, for Kubernetes, like we are using AKS. AKS is also a GUI. And to manage EKS, what we are doing? We are using kubectl command. We are using this command line and all. OpenStack, what it does, it is for those person who do not like more of the command line interface. Everything is GUI. Underlying, you have the logic of Kubernetes, but you will be able to create the pods, delete the pods, create the deployment, delete the deployment, look into the deployment, everything in a user interface. That's it. But if you know the logic of Kubernetes, you will be able to handle that OpenStack graphical user interface also. Internally, they're using Kubernetes. Understand it?
Okay. Apart from Kubernetes, what other things they will be used with OpenStack?
OpenStack is meant for Kubernetes only.
Only for Kubernetes. Okay.
Yeah.
And Terraform like that?
No. OpenStack is not for Terraform.
Okay.
So what is OpenStack? Is this a GUI version of Kubernetes?
Do you know, Ashwini, what is OpenStack? Ashwini.
Sir, not exactly, but it is similar platform like managing nodes. Not exactly, sir. Please tell us.
Yeah, OpenStack, what Shakil says, it's the same. It's the graphical user interface for managing Kubernetes. It's a platform where you can manage Kubernetes by using some graphical user interface.
Okay. Thank you, sir.
Anything else?
Oh, sir, can we call it as a VMware manager?
No.
No?
You cannot, no.
Okay. Okay, sir.
Okay, cool. Then let's connect again tomorrow, and then we will talk about what is tomorrow. Tomorrow is a Saturday, right?
Monday now.
Then we'll connect Monday. We'll connect Monday, and then I'll explain you about how to connect in bit. See, guys, you have 2 days time, so practice everything.
Yes,
because I'll just talk terms from Monday's session. That yes, this is a replica set. I'll just copy and create something which is very similar to a replica set. Now you should know what is replica set. So this you will know only when you will practice. Otherwise, no. Okay, cool. Let's connect again on Monday. Thank you.
Thank you, sir.
Yeah, thank you.
Bye-bye.
Bye.
Sir, are you there? I'm not sure.
Yeah, Ashwini, I'm there, but I have to drop, Ashwini. Let's talk on
Okay.
Monday.
So can I get your, I need to discuss some queries. Can I get your number?
I won't be able to provide you.
Okay.
Maybe
I
this
will
guy
check with
is
the
safe
consultant.
and Kubernetes.